Get ready for what might be the greatest lesson of mathematics you've seen so far. Not because I'm teaching it. That's true every day. But because this is solving by elimination. I want you to prepare for the emotional response you might have in this lesson. There'll be two emotional responses. The first one might be like, oh, this math thing's for real. I'm so glad I stayed on my math journey till now. And the second one, be ready for this one, is after I show it to you, you might be like, why didn't you show us this before? Yeah? And both those reactions are legitimate, but it's incorrect to believe that you should have learned it in a different order. This is the perfect order to learn this stuff. Anyhow. Here, sit here. Are you done? Yeah? Okay. Solving by elimination, day one. Hopefully that doesn't scare you, that day two is coming. You know when there's a day one and a day two. Could be trouble. So our goal, solve a system of linear equations using an algebraic strategy. Like, isn't that what we did? We're already doing that. That's what substitution is. Like, here's another way. Yeah? You have now seen how to solve a linear system by graphing or by substitution. There is another algebraic method as well. With each new method, you have more options for solving the linear system. That is, if the numbers are big or if they're decimals, probably substitution's better than graphing. Now we'll find out when this one might be better. Elimination is a method for removing a variable from a system of linear equations by either adding or subtracting the equations. Oh, come on. It's highlighter time. What? By either adding or subtracting the equations to get an equation in one variable. What? When the coefficients of one variable are opposites, you add the equations to eliminate a variable. And when the coefficients of one variable are equal, you should subtract the equations. I'm switching. Let me show you. My crazy daughter has a whole set of highlighters that she uses. And yellow is like, that's important. And red is like, this is the whole deal. This is the most important thing I've seen in a long, long time. It's a very strong method of learning to every once in a while break out the highlighter and go, whoa. If you don't have a highlighter, maybe underline it, circle it, put a big star beside it to go, whoa, that's big. Now what I'm going to do is I'm going to teach this lesson a little bit backwards. Then I'm going to skip the rest of what's on your page. I'll come back to it in just a second. But on your page, it tells you how to solve by elimination. This could confuse the issue if you haven't seen what I'm going to do first. And their example might confuse the issue. Let's jump right ahead to example 2. And then I'll go back. After seeing example 2, then you'll appreciate the previous stuff more.
Wait, so if it's two negatives or two positives, you can't do this?
He asks a great question. If there's two negatives or two positives, you can't do this. And the answer is no, you can do it, but you might have to use a different operation. And I'll show that off in just a second. Yeah, great question. If I was, this one actually is a fairly friendly substitution one. I could solve for x in the first one, y in the first one, y in the second one, not too bad. So this one doesn't show off elimination as well as some of the later ones will. Maybe. You might love this. Now, I'm just going to read this question, and hopefully somebody will tell me what to do. And it won't be me that just tells you. It'll be like, oh, that's cool. Okay? First equation, x plus y equals 2. Second equation, 3x minus y equals 2. I coach a 7-year-old hockey team, and you should see them go nuts. They have shift times. Yes? They know exactly when they're going on. A buzzer goes every 2 minutes, and then they jump off the bench and they go. So they know. They're looking at the clock, and because they know it's their turn to go. So they're literally vibrating. Right now, the method of elimination looks at this question, and it's vibrating, like little 7-year-olds going, oh, I can do it. I can do it. Let me reread so we can see if there's somebody out there who can tell what to do. I'm going to reread the sentence in red. When the coefficient of one variable are opposites, when the coefficients of one variable are opposites, look at the y's. Y negative y. Dun, dun, dun. Where is it? When the coefficients of one variable opposites, you add the equations to eliminate a variable. What? What could I do with these two equations that would eliminate one of the variables? Just add the equations. That's when you can be mad. You can be like, why didn't you just tell us we could do that? Here's how you handle it. You literally draw a line like you did when you were adding numbers in the column method way back in grade 5. Yeah? And you just write the word add here. Trust me when I tell you, at least do that. Write add out front. For exactly, he asked the question, he said, well, does it not work if they're both negative or if they're both positive? Hold on. We're going to use add here. Ready? 3x plus x. That's supposed to be the easy part. 4x. This pen's very valuable, so I'm not going to do it, but I'm going to pretend to do it after this next step. Y plus negative y. 0. Nothing. Gone. Eliminated. I should drop the mic now. Like, that's it. Go home. That's elimination. Beautiful. 2 plus 2. 4. I left a little gap there. You don't have to leave a little gap there. I left the gap to go, yes, I thought about it. Y and negative y add and cancel out. Let me just say what I said in the substitution lesson as well. What's beautiful about this equation? It's just x, and it's really simple in this particular case. Elimination often pulls this off. Now you're like, I'm just going to do elimination all the time. I'm like, hold on. There's 2 days of elimination coming up. There will be situations. This one was rigged up as the first one to look at. There are going to be other situations coming up. So don't just sell the farm for elimination just yet. But I think that does deserve one of the biggest smiley faces you've ever wrote to go, wait a minute, this algebra there might be more to this than what we've seen so far. Well, hopefully you know how to solve the equation 4x equals 4. Hopefully that's not a problem. It divides both sides by 4. I'm going to show the extra step this time, but you probably don't need to. X equals 1. Now, how am I going to get the y? I don't have a beautiful equation. She said equation 1. Why did you choose equation 1? Because it was the first one? Oh, you could just choose the first one. But what is better about equation 1 here? Yeah, the coefficients. It's just an easier equation to work with. And you get to choose. It'll give the same answer in both, or else math is broken. That's stunning that will happen. But if x equals 1 is truly the x value of the point of intersection, then the y values will both be the same. Yeah. So let me write the fancy sentence here, because they're paying me for this, so I'll write it out. Sub x equals 1 into 1. But again, it doesn't matter which one I choose. And I get 1 plus y equals 2. Hopefully that's not too challenging. And I get y equals 1. You really should check both equations, but I need to tell you it probably is right for equation 1. That's the one I subbed into. So I'll only check 2. Left side, right side, 3x minus y, 2, 3 1s minus 1, 2. I did that quick on purpose because I hope you've been checking along the way. And if you haven't, well, maybe you should get to it. Therefore, the solution is 1 comma 1. Oops. 1 comma 1. That is very powerful mathematics, but pretty simple. In my world, that's what we call beautiful mathematics. Stuff that's powerful, but also pretty simple. Most people are like, okay, I think I can do that. Now be ready. Elimination get out of hand. What is it about this question that made elimination work out very well? Well, it was y and negative y. It was ready to go. So we got to talk about what if they're not quite as ready to go. That's the rest of the lessons for the rest of today and tomorrow is just another set of equations go, ooh, this one's a little different. It's a little weird. How are we going to make elimination work here? Okay. Any questions about that example, though? So let's go back to the instructions then. That might make more sense now that you've seen it. Okay? Here's the overall instructions. Rearrange both equations so they look like this. You don't have to do this, but this is the best way to handle it when you're first learning. Get the x's and y's over on the left side, the number over there. Set it up the way you see, the way that one was set up. Do you see what I mean? X and y over here, number over there. Get it all lined up to do elimination. This one was already ready to go. But if it's not, we'll get it ready to go. Number the equations 1 and 2, as before. Choose the variable you wish to eliminate by identifying matching coefficients. What if they don't match? In fact, you should be sitting there going, Mr. Todd, you better finish this lesson off at some point and tell me what to do when they don't match. I will. Just like substitution, day 1, day 2, we'll just keep escalating until we think we can handle everything. Either add or subtract. Ooh. That's going to get my yellow highlighter. That's not like life-changing, but it's important to know I can add or I can subtract. To eliminate one variable. Solve the resulting equation of one variable. This is after step 6, you should be pretty happy. If you get to step 6, you'll be like, okay, solve that for x, sub it in to get y. That part of it, most people have good luck with. Substitute that value into the original equation and state the answer and check. Those are fairly similar to substitution. And here is a completed example. Let's look through the completed example. I don't know. Everybody's different. Some people like just looking at a completed example. Some people like walking through it with me. So I do both at once. Yeah? Here's a completed example. Again, for some of you, this will be like, I really get that now. Some will be like, that's confusing. Can you just do one with us again? I'm like, okay. So you take a look and you go negative 3x plus 4y equals 7. 3x plus y equals negative 2. This is primed and ready to use elimination. What is it about those two equations that tells you that it's ready to go to do elimination? Yes. And I know, what if it's not opposite signs? What if the numbers are different? Yes, I'm going to teach all that. But for now, we'll look at examples where, hey, negative 3, positive 3, ready for elimination. And ready for elimination by adding the equations. And when I add the equations, great things happen. The negative 3x and the positive 3x cancel. That's the elimination part. X has been eliminated from the equation temporarily. We haven't got rid of x. We've just taken it out of our equations, and I ended up with 5y equals 5. Solved, y equals 1. You know how I feel about this. I like putting a box around those, because I'll be looking for it later, so I may as well have a box around it. Take that y equals 1, and you can sub it into either equation. And here, this worked out good because they put it into equation 2, letting you know you can use either 1 or 2. Sub that in, and maybe now you're a little bit like, oh, that's why all those, in grade 9, we were always subbing stuff in. Seemed like it was useless, but now that skill is important. Sub that in and solve for the x, and once you have that, then you have the answer. Ooh, don't put a check mark there. You have the answer, and then you go over here and you just check them as before. But I pause for questions, if that's weird looking or if you want to talk about it. Questions?
What happens if you subtract instead of adding the equation?
Subtraction won't eliminate a variable here in this particular situation. So if the signs are opposite, you're going to have to add. Lots more to tell you, though. You say, what if the signs are the same, but I do want to add? I'm going to show you lots of little maneuvers we can do. So there's lots of things still to tell you, and they might already be bouncing around in your head. Okay? For now, we're going to talk about ones where it's all lined up and ready to go, and then we go, okay, now what happens if they're not lined up and ready to go? Okay? That's good? I'm going to do example 3, but then I'm going to do one more to sort of get ready for tomorrow. Okay? So these two equations, when they give them to you like this, see, we used to like y equals mx plus b. For substitution, y equals negative 2x plus 5 minus 5. You'd be happy with that. I'm going to say, if you want to do elimination, bring everything to one side. And I'm going to just move it over and then pause for questions. Please let me know if I've gone too fast, because I really don't intend to go too fast. So I've taken equation 1, and I've moved the 2x over, and I've taken equation 2, and I've moved the y over. This is what I was talking about. Make it look like ax plus by equals c. X's and y's on the left, variables on the left, numbers on the right, just to get it all lined up sort of in columns, if you want. Then you look and go, okay, now, does something line up? Something does line up. Which of these, the x's or the y's, lines up? 2x and negative 2x. Get ready for someone to ask a different question in just a minute about this situation, and we'll talk about it, okay? But for elimination, if you get the chance to add to eliminate a variable, that's the one to use. Negative 2x and 2x, eliminated. Y plus y, 2y. Negative 5 plus negative 1. You know what? Very smart people often make mistakes with simpler questions like this. And I know why it happens. It's happened to me on the board before. You're keeping track of elimination. You're keeping track of, should I use x's and y's? You're doing all the algebra, and then it's easy to go negative 5 plus negative 1 and write down a wrong answer. I think it's my fatal flaw as a mathematician, is losing my attention on the easy parts of the question. You got to find a way to stay focused, or maybe punch them into your calculator in the middle of all this. Go, hey, my brain's doing a lot of crazy stuff here. I'll use my calculator. You'll know when you're doing these for homework. You'll know if you're doing that. Then divide both sides by 2, and I get y equals negative 3. Oh, little rectangle. Now what do I do with the y? Whoa, sub y equals negative 3 into 2, what 2? Oh yeah, I didn't label them. And that's why we label them. Don't forget to give them a label. So I can go back to here. And which one did you like? 2. So she's going to go negative 2x equals negative negative 3 minus 1. Careful there, right? The negatives can mess you up in a hurry because the equation 2, and maybe you went down here, and that's fine. But I went after that equation. But any of those you can sub into, and you'll get the right answer. Whichever one you use, you should get negative 2x equals 3 minus 1. Negative 2x equals 2. Divide by the negative 2. X equals negative 1. And I did that fast on purpose, not to intimidate you, but just sometimes in the lesson, I like to go a little faster so we stay focused on the idea, not hung up on the individual algebra. Hopefully those steps are something that you won't have much trouble with. I've been trying to alternate, though, with checking using left side, right side check, and checking using Desmos, so that you have both weapons available. So let's punch these in and see if it works out. Y equals negative 2x minus 5. I've already forgotten. I said it out loud to try to remember. Who's with me? Can yell it out. What's the first one? Y equals negative, no, the equation. Negative 2x minus 5. And the second equation?
Negative 2x equals negative y minus 1.
Equals negative y minus 1. Answer, I can click on it. I got negative 1, negative 3. Is that what I got when I did the? Yes, it is. Although I got a really AP question for you. If the computer can do it, why do we have to know how to do it?
Because you don't have the computer on the test.
you don't have a computer on a test. I agree. And then someone says, why don't they just give us the computer on the test then? If we've got these devices that can get the answers, why do I have to know how to do it?
You're not improving on it, you get it.
Yeah, somebody's got to build the computers. Like an AP class like this is not designed to just punch things into a computer. We want you to be the people who build the computers and build the programs and everything and improve on everything that's out there. So yes, we got to know, whoever built that Desmos certainly knew how to do this. Yeah? Therefore, and I'll use the other phrasing just to bring that back in, the point of intersection is -1, -3. Good? All right. Now, I'm not done though. It looks like I'm done. You might think, oh, I'll get it to the homework. Yeah, I'll wrap it up pretty quick. I intend to wrap it up pretty quick. But was there another option at this moment here? I'm going to recopy that onto another page. I'm going to write those down, and I'll see if anybody can see what the other option to go with was there. So it was 2x plus y equals -5. And the other equation was -2x plus y equals -1. Let me just make sure I copied those down. Is anyone finding that in their homework? Every single mistake is that you just copied the question down wrong? Yeah? So you can see I always double check because that drives me crazy. 2x plus y equals -5, yes. -2x plus y equals -1. There's another option. And this one, I could have used that option. Yeah, subtraction would have eliminated the y. Now, I think you'll find that subtraction is more prone to errors than addition. So this isn't a situation where like, ooh, let me show you a better way. Let me just show you the other way. Every once in a while, subtraction will be better. Usually addition is better. So this time, instead, I'm going to subtract the two equations. So 2x subtract -2x. Do you already see the potential danger of subtraction? Is that 2x subtract -2x is not everyone's mental math automatic like adding was. So that's the difficulty of subtraction sometimes. 2x minus -2x is 4x. And again, if that doesn't come quickly to you, you're seeing the problem with subtraction, why we often lean towards teaching addition if we can. Okay? Y minus y eliminates. And then here we go again. -5 subtract -1. Oh, but you took science, right? This one's not so bad. 5 electrons subtract an electron equals 4 electrons. All right, so that's, I don't know. This whole negative thing, maybe we just need a deeper understanding of it, and then it's going to be okay. But then you'd go through the steps, and when I divide those both by, sorry, pressing all the wrong buttons, typing the wrong thing, exactly what I was talking about. I felt like I was near the end, and I got distracted. Divide those both by 4, and I get x equals -1. Is that what I found x to be? It should work. It'll be okay. And then if I subbed x equals -1 into, and I'll call it equation 3, because on the other page I had 1 and 2. That's just being very careful there. 2 times -1 plus y equals -5. I'll do this quickly. Don't get excited that I'm doing it quickly. I'm just showing you that with the proper steps, I get the same answer. Was the answer -1, Okay, so math isn't broken. You could subtract or you could add. Mr. Todd's personal advice, try to add. Okay, now, in the interest of being ready for tomorrow, because it might feel like, well, you're rigging up all the examples to make them nice. I want to know that elimination is going to work anytime. So here's just a little bonus example. You don't even have to copy this down if you don't want to. A little bonus example to think about what's going to happen tomorrow. Bonus example. Not a bogus example, a bonus example. Yeah, this is my bonus example so that you can go home tonight, not get insomnia laying awake going, yeah, but Mr. Todd, what happens if the coefficients are all different? Elimination is not going to work, and I don't want to do substitution. I say, let me just show you a little bit about what I'm going to show you tomorrow so you don't go home all upset. This system is not ready for elimination. 4 and negative 2 don't line up. Negative 3 and 7 don't line up. Agreed? But I can do something to one of the two equations to make them line up. What could I multiply only one of the equations by to make them line up? Yeah, if I just take this and multiply everything by 2, negative 4, negative 4x plus 14y equals 10. And I'm not going to do anything to equation 1. 4x minus 3y equals 1. Aren't you happy now? And now your elimination knowledge is almost complete. You're like, oh, well, if they don't line up, I'll choose a number to make them line up. Then I could add and get the y value, take that in, sub it into there. And get the x value. I have skipped a couple of steps there on purpose to stick to the idea. The idea is like, it'll be okay. I'll be able to eliminate now any two systems. Make the coefficients anything you want, Mr. Todd. I don't care. 7s and 4s and negative 3s and 2.76, don't care. I'll just multiply them by clever numbers. And that's what tomorrow's lesson is all about.
Why don't the 4 and negative 2 line up?
Because when I add 4 and negative 2, I get 2. They don't eliminate. To eliminate, we need them to have the same coefficient and opposite signs if we want to add. You're like, what if they're not opposite signs? Well, you could multiply by negative 1. All right? I'm mostly giving away tomorrow's lesson, but I don't want you to go home thinking that elimination isn't awesome, because it is. But day 1 is just like, let's do some that are just nice and easy, shall we? It's like, I'll just give you, it's like for your first basketball practice. I'll just give you some nice bounce passes. We'll just get warmed up on this, and then tomorrow we'll get a little crazy, all right? Any questions on that? What does homework say? Homework says, oh, it's on a handout.